All right, good morning, everybody. It's Monday, May 4th. Starting kind of the final countdown here, the last 15 days of school. So hopefully you guys had a good weekend. We can get back into chapter 4. You can see that we're moving on to section 4.4 today. Section 4.3 was working with the number e, the natural number e, which proved to be a little bit frustrating at times and kind of murky and confusing. And unfortunately, we're going to kind of continue on with the theme of, not necessarily difficult work, but just a little bit of confusing stuff going on, maybe a little bit of uncertainty in terms of if we're doing it correctly. So section 4 is about logarithmic functions, okay, and logarithms. So logarithms are something that we really spend very limited time working with in high school math, but it's very good for you guys in terms of exposure going into your whatever freshman level math class you guys are going to be taking next year. So it's going to be, like I said, a little bit strange today, but hopefully with the notes in the note sheet, you'll be able to navigate the assignment with not running into consistent questions. Okay, so what a logarithm is a logarithm is just an alternative to an exponential expression, okay? It's just really strange. It's kind of a strange altogether concept. So you've probably noticed the log button on your calculator. Most of them are in the upper left-hand corner area, and it literally just says log, okay? So it's kind of a weird concept, but here's the way that this works. This is something... It's just another expression. It's just another function, essentially, okay, an operation. So the way that we would read this particular question right here is this says, what is the base for logarithmic value of 64? That's the long way of reading it. The short way of reading it is, what is the value of log base 4 of 64? And the answer is 3. Now, I will explain, because even not being in the room with you guys, I can tell your eyebrows just kind of wrinkled up a little bit there. Here's how we know the answer to that is 3. A logarithm or a logarithmic function is just a mixed up exponential expression. So the exponential expression, or the way of writing this, is whatever the base in a logarithm is also the base of the exponential expression. It's just weird that this is the fourth, log base 4 of 64 means this. If 4 is a base, what is the exponent needed to put on it to give you an equivalent value of 64? So it's almost like saying this. Instead of saying what is the log base 4 of 64, you could say what is the exponent on 4 that gives me 64. So 4 to the third power is 64. 4 times 4 times 4 is 64. Okay? So these are kind of equivalent things, or inverse concepts, if you will. An exponential expression or an exponential equation versus a logarithmic equation. So I could give you, and kind of the obvious thing here is logs can have any base that you want. You could have log base 3 of 81. What is log base 3 of 81 equal to? What is x? Well, another way of writing it is 3 raised to the x power has to equal 81. So these are just equivalent expressions to one another. This is the exponential form. This is the logarithmic form. So 3 raised to what power is 81? That would be 4. 3 to the fourth power is 81. So the log base 3 of 81 is 4 also, okay? Now, what we're going to see here is underneath my notepad here, I've got the actual notes sheet that I'm going to kind of walk you through here, okay? The general idea that we need to keep in mind, though, is this. When you see a log, whatever the base is, that's the base of the exponential expression, and almost what you're trying to evaluate for the log is the answer to the exponential expression. You just got to kind of keep that in mind and bounce back and forth, okay? So, having said that, here's the actual note sheet. I might pull that back up if we need it, but we're going to kind of talk our way through this. Okay, so logarithms. The most common logarithm we have are base 10 logarithms, which makes perfect sense. Our natural number system is based on 10 digits. So the most common thing we have is log base 10. Okay, so you can kind of see here log base 10 of x equals b. What that means is that 10 to the b power is equivalent to x. We already kind of have described that. Base of common logarithms is 10. Okay, so the most common thing that we encounter here is a 10. However, we talked about last week that in calculus, the most useful base for exponents is e. Therefore, the most useful base for logarithms is also e. Okay? So one of the things worth mentioning is this. If we do a problem like this, log base e of a certain power, log base e of x, this is such a common used logarithm that we give it a, like, not that it necessarily needs one, but instead of writing out log base e, it's just written as ln. And so you've probably also noticed the ln button on your calculator. It's right below your common logarithm button. It's log and then there's the ln on it. When you see ln, it means log base e, not log base 4 or log base 3 or even log base 10. It's log base e. Okay? So just got to keep that. It's another thing we got to keep in mind. ln stands for a logarithm where the base is e. So the natural logarithmic function denoted as ln x, or ln of x, or natural log of x, is ln x equals b if and only if e to the b equals x. So again, even though we don't see it, there's an e right here. E raised to the b power is x. So it's just like any other logarithm. The base of the logarithm is the base of the exponent, and the answer of the logarithm is the exponent of the actual power function. So again, ln of x can be read as just that, ln of x, or natural log of x. It makes more sense, obviously, to read it as natural log of x. Okay, this definition implies that natural logarithmic function and natural exponent functions are inverse functions. They can be written in the other form. So when you see something like this, ln of 1 equals 0, how do we know that the natural log of 1 is 0? Because e raised to the 0 power is just any number raised to the 0 power is 1. Okay? Natural log, if you have these together, they basically or essentially cancel each other out. What is the natural log of e? It's 1, because that would be e raised to what power is equal to e? Well, if you want it to be equivalent to itself, you raise it to the first power. Natural log of 1 over e. Well, that would be e raised to the negative first power is going to be 1 over e. So it's kind of weird, but hold on, I'm going to sneeze. Maybe. Oh, false alarm. Anytime that we evaluate logarithmic functions, typically what we do is we turn them into exponents because we're just so much more familiar with them written in exponential form. Okay? So any one of these, if you were evaluating the natural log of one of these numbers, you'd probably rewrite it in exponential form to get a better idea of it. Okay, now, good news I have for you guys is this part. It says, the notes get talking about inverse functions and what graphs look like. We are going to skip the graphing component of this and focus on just the properties of logarithmic functions. Okay, so you can see that down here. And here's where you'll get a better sense of what you're actually probably going to encounter mostly on your assignment today. So the properties of logarithmic functions. Inverse properties of logarithms and exponents basically say this. If you have natural log and e put together, those are inverses. So it's just like anything else in math. If you have inverses paired together, they cancel. It's no different than having something like this. If you have the square root of x and you raise it to the second power, square rooting and squaring are inverses. They cancel each other off, leaving you with whatever's underneath. Well, the same thing happens when you have the natural log of e. If you have natural log and e paired together, so like if you were searching for the answer here, the natural log of e to the x, just like squaring and square rooting cancel, natural log and e cancel, leaving me with just x, so the value is x. It's the same thing if you raise e to an exponent involving the natural log. E to the natural log of x, the e and the natural log cancel each other off, leaving me with just the x, okay? So, I mean, obviously what we could have done here to make that make more sense is this. If you're going to try and find the value of the natural log of e to the x power, remember, this is e raised to what power is e to the x. Well, obviously, e raised to the x power is going to give us e to the x. It makes a little bit more sense if we turn it into an exponential expression. All right, here's the other thing, or the other properties. If you have a natural log of two separate things being multiplied together, you can expand them, or basically pull it apart into two separate natural logs. So the natural log of a product is equivalent to the natural log of the first term plus the natural log of the second term. All right? Similarly, for a quotient, if you have the natural log of a quotient, that is equivalent to the difference of those two terms' natural logs. Natural log of x minus natural log of y. And then here's the other kind of obscure, weird one. If you have the natural log of something raised to a power, that is equivalent to the natural log of that same thing multiplied by that as a coefficient, okay? So essentially, or effectively, if you have an exponent, you can take the exponent, pull it out front, and then you no longer have an exponential expression. So what you're actually going to be doing on most of your assignment is just using these basically 5 principles to just rewrite natural logs. So you can see how simple it gets down here. If you have the natural log of 10/9, it says expand the logarithmic function or expression. All you do is you pull it apart using the difference property, basically. Natural log of a quotient is equivalent to the difference of the two natural logs, natural log 10 minus natural log 9. Natural log of square root x squared plus 1, well, if you turn x squared plus 1 inside of a square root into an exponential expression, so raised to the 1/2 power, this is the exponent rule. You can pull the exponent out front and write it as the product, and there's no longer an exponent there. This one, natural log x times y plus 5, you can break that apart considerably because you can break it apart as the difference of the top and bottom, so natural log of xy minus natural log of 5. But then this is still a condensed natural log. It's a product, x times y. So natural log of x plus natural log of y minus natural log of 5. So if you haven't already picked up on it, we're doing some pretty weird expansion and contraction of expressions. Today you just need to bear with me because tomorrow we'll get into how this benefits us at all, okay? So down here you can see you got just a couple different things going on. Natural log of all this in the bracket. Well, inside the bracket is a product. So products are equivalent to sums. Natural log x squared plus natural log x plus y. Then the first term has an exponent, so we can rewrite it, bring the 2 out front. 2 times natural log of x plus natural log of x plus 1. Yeah, or there's a different alternative to that, but you get the point. Over here then, it's the exact opposite. It's condensing into single logarithmic expressions. Natural log of x plus 2 times natural log of y. So working in reverse, if you put this 2 back as an exponent, it'll be natural log of x plus natural log y squared, and then rewrite the sum as an original product, natural log x times y squared. Okay? Similarly down here, 2 natural log x plus 2. Anytime there's a coefficient and you're trying to condense it, you'd move it back up to an exponent. So it's natural log x plus 2 squared minus natural log, and same thing here, move the 3 back up, x cubed, and then rewrite this as a quotient since it's a difference. Natural log x plus 2 squared over x cubed. Okay, number 3 is very similar to those. So it's kind of weird today, but it's a lot of like expanding and contracting of these expressions based on these simple natural log properties. So just like always, shoot me any of your questions. I'll try to put together a fairly condensed but thorough clarification video tomorrow based on what you guys let me know your needs are, and we'll go from there. All right, guys, have a great Monday, and I'll talk to you tomorrow.